Hi, this is Akhil Pandey, Assistant Professor, Civil Engineering Department. I am here to discuss about Photogrammetric Survey, Part 2. In our previous lecture, we discussed about some important terms used in photogrammetric survey, some different types of photogrammetric survey, that is terrestrial photogrammic and aerial photographic survey. We also discuss about aerial photograph and the important terms that are used in aerial photogrammetric survey. In this lecture, we will discuss about scale of vertical photograph, flight planning for aerial photography, what are the flight plannings, what are the plannings basically performed for the aerial photography, and how to calculate the number of photograph required to cover an area. In this topic, we discuss about how to calculate the number of required photograph to cover an given area. Now, talking about scale, first of all we have to discuss what is scale. Scale can be basically of two types. One that is known as engineering scale and other type is known as representative fraction. Representative fraction. In this type of scale, that is engineering scale, we denote clear instructions, that is 1 centimeter is equal to 1 kilometer, for example. And in representative scale, we basically represent in a fraction form, that is 1:100 or 1:1000. Talking about scale, talking about definition of scale basically defined as map distance upon ground distance, and this concept is used in a scale of vertical photograph. Now, talking about scale, aerial photography do not have uniform scale. It means by looking at this figure, we can easily determine that this is a ground. It's talking about point P, and if we are talking about point S, those point have different height from the datum. Therefore, this type of scale that is used in a aerial photography do not have any uniform value. It can be changed. For example, if we are talking about point P, then scale can be f upon h minus this point h1, and talking about that point S, scale f upon h minus h2. Now, moving forward, with that we know that if the terrain to be photographed is flat, the photographic scale can be taken as vertical, and if the altitude of the camera is known, that is the datum can be selected and scale of a photograph can be determined from the datum. Now, moving forward, to find out the scale of a vertical photograph, let us see this figure. In this figure, this is a lens, optical axis of a lens, and this is a point on the images. The distance between that optical lens and the point of an image is denoted by f, that is focal length of camera, and these are the different points that are situated on a ground. Now, according to the scale, that is map distance upon ground distance, and consider two different triangle, that is OPQ and O small p and small q, that is this triangle, this and this, and by using the properties of similar triangle we can determine the scale. Now, scale by using similar triangle, properties of similar triangle can be defined as PQ upon capital PQ, that is equal to F upon H minus H1 for point P. And if we are finding the scale at a datum level, then it can be defined as, it can be represent as F upon H, that is scale at a datum level. Generally, scale of a photograph for any ground height or ground elevation is given by this following equation, that is S is equal to F upon capital H minus H. Here H basically denote the average height, S is a scale, capital H is the altitude of a aircraft above the mean sea level, that is datum. This and small h represent the height or a elevation of a ground above the mean sea level, that is this. For point S, H is equal to S2, and for point P, H is equal to H1. F again, F is basically a focal length of a camera, that is the distance between optical lens and a point on a photograph. This we also calculate the length of a line by using these equations. For example, if the ground coordinate say x and x comma y, that is this, capital X comma capital Y, these are the coordinate represent on a ground, and the photographic coordinate are, that is this x comma y at point P, then in order to find out the length of a line, we can use this expression, that is small x upon capital X is equal to, it is basically a scale which is equal to F upon H capital H minus small h. Similarly, for y coordinate we can also use this equations, small y upon capital Y is equal to focal length, that is F upon capital H minus small h. Now, length of a line PQ, that is this length can be calculated by using the equations, that is at point P xp is equal to capital H minus small hp upon focal length into small xp. Similarly, y coordinate at a point at a ground level at point P is represented by capital H minus small hp upon focal length into yp, that is coordinate on a photograph. Similarly, at point Q, this we can also calculate the coordinate by using this equation, xq is equal to, now talking about that point Q, equations can be changed, that is h minus hq upon focal length into the small xq, that is a coordinate on a picture or images, and coordinate y coordinate on a ground at point Q can be calculated by using this equation, h minus h small hq upon focal length into coordinate y coordinate at point Q on a image. We can also use the distance formula for calculating the true horizontal distance. Now, in order to find out the distance between P and Q, as earlier we find out the different coordinates, and by using distance formula, the horizontal distance PQ can be calculated as under root xp minus xq ka whole of square plus yp minus yq ka whole of square. By using this formula, we can calculate the length of any line. Take some example. on a scale, numerical on a scale of vertical photograph. A line PQ measure 12 centimeter on a photograph is snapped by a camera with a focal length of 22.5 centimeter. The same line measure 4 centimeter on a map drawn to the scale of 1 by 45,000. We have to determine the flying height of an aircraft, and the average height or altitude is given here is 360 meter. Now, on discussing this question, first of all we write the given data. Here the given data is average altitude, that is h 360 meter, scale is given, that is scale s 1 upon 45,000, and in this question a photographic scale of a camera, that is of line that is measured 12 centimeter, and that on a map is of 4 centimeter. These are the two different measurement using a scale. First of all, we have to calculate the photo scale. For calculating the height, that is h, we have to find out, we have to determine the flying height asked in a question. So, first of all we use this formula for finding the photo scale, that is photo scale upon map scale is equal to photo distance of a line PQ upon map distance of a line PQ. Focal length is given 22.5 centimeter, converting into a meter we get 0.225 meter. Photo distance is given 12 meter and map distance is given 4 meter, and map scale is given 1 by 45,000. Now, in order to calculate the average altitude, total height, average altitude is also given in a question, that is 360 meter. In order to calculate the height total, we use that formula we discussed earlier, that is scale s is equal to f upon h minus h. We have to calculate this, and we have also to calculate this. In order to calculate a scale of a photograph, we use that formula we discussed earlier, that is photo scale upon map scale is equal to photo distance of a line PQ upon map distance of a line PQ. By using that formula, we get the value of a scale, that is 1 by 15,000, and by using this scale in the formula s is equal to f upon h minus h, we can calculate the height. Now, as we are seeing in this numerical, s is equal to f upon h minus h1. Here h1 is basically a average height, that is equal to 360 meter. F converting into a meter, we obtained 0.225. h1 is 360. Putting all these value in this equation, we obtained this h minus 360 is equal to 0.225 into 1500, that value is about 3375 meter, and by adding this h1 we get the total height of an aircraft, that is capital H is equal to 3375 plus 360 is equal to 3735 meter. Again, by figure we can also discuss all these equations once again. Here, assuming this is a datum, this is a aircraft, and these are the basically images that obtained. It is datum h1 360, this is f focal length 0.225 meter, and we have to calculate this overall height h. So, in this way we can calculate this total h, which is about 3735 meter. Now, talking about some flight planning for aerial photography, we discuss in this topic about different planning that are conducted during aerial photography. What are the basic information we need for the flight planning are: area to be surveyed, focal length of a camera, scale of the photograph, that is S, focal length of a camera, that is small f, longitudinal and side overlapping, we discuss in next slide, and approximate ground speed of an aircraft in a stable air. To cover the entire terrain to be surveyed, the sufficient photograph will suitable and with suitable overlapping should be taken. What is longitudinal overlapping? The longitudinal overlapping is also known as forward overlap. In this figure, this is basically a first exposure by a camera and this is a second exposure by a camera. This common overlapping is known as longitudinal overlapping. The overlap of a photograph occur in a direction of flight. It is a direction of flight. The overlap of a photograph occur in a direction of flight is called longitudinal overlap, this portion. And the minimum overlapping here, the minimum longitudinal overlapping which we used is about 60%. Now, talking about side overlapping, the overlapping between the adjacent flight line is called an side overlap and the value which is considered is about 30%. For example, if we are covering an area of length L and width B, so first of all we have to perform overlapping in a direction of flight. This type of overlapping is longitudinal overlapping. And overlapping in this direction, adjacent flight, that is first, second, similarly third phase, fourth phase and so on. And overlapping in a direction of flight is longitudinal overlapping, and overlapping between two adjacent flight, this is basically referred to the side overlapping, which is about 30%. So, why should we need overlapping in an aerial photography? These are the following reason due to which we basically overlap, that is longitudinal overlap or side overlap. Overlap is provided to orient prints so that there is a continuous flight strip formation. For example, if we exposure, if we covered a different areas, that is this, and we doesn't overlap this, how can we create a continuous strip? In order to maintain the continuous strip, this type of overlapping, that is longitudinal or side overlapping, is performed. Now, overlapping is also provided so as to discard the highly distorted outer portion of the photograph. By photograph outer portion, in order to discard the outer portion, overlapping is performed. Overlap portion is also used for stereoscopic vision. So, what is stereoscopic vision? We will discuss this in our next lecture. And the overlap that is provided is also provided to prevent the possibilities of different gap that is left because of deviation of aircraft from the flight line. This is flight line, and due to wind pressure that aircraft is deviate from its path in this way, and in order to prevent the possibilities of gap due to the deviation of aircraft, overlapping is performed. There are some other reason also due to which we performed overlapping. The other reason are drift and crab. Drift and crab. What is drift? Drift is basically failure of an aircraft to remain stay along the with the line of flight in a direction. This is a line of flight, and due to wind direction, as we discussed earlier, it can deviate from its path, and this phenomenon is known as drift. So, drift can be defined as a failure of an aircraft to remain stay along with a flight line. There is another term, that is crab. What is crab? Crab basically occur when a camera is not square with respect to the direction of flight at a time of exposure. That is, in this figure we can see that the camera of the camera is not in a square position, that is not in this position. It basically tilt from its position, that is square, and convert it in look like a rhombus. So, therefore, crab, when a camera is not square with respect to the direction of flight, then the error which occur during the aerial photography is known as crab. There is a small difference between drift and crab. Drift is basically a deviation of an aircraft, and crab is basically a deviation or a change in a direction of a camera at a time of exposure. Now, talking about altitude of aircraft. What is altitude of aircraft? Altitude, that is h. If this is a ground and this is a datum, assuming aircraft, then this is a line of flight, then this total distance h is basically is defined as altitude of aircraft, and it can be calculated by contour interval into C factor. The C factor basically varies from 500 to 1500 without any unit, and h is basically a flying height. What is contour interval? Contour interval is basically a, what is contour? Contour is basically a line joining a same elevation, point of same elevation in this way, and the distance between two different contour is known as contour interval. In aerial photography, it can be defined as a interval between two different point at a time of exposure. Here this is contour interval, and C factor, the value of C factor is about 500 to 1500, and by using this we can also calculate the altitude of aircraft, that is capital H. Now, talking about area covered by one photograph, we took some example. Now, if this is a length and this is a width B of an area to be surveyed or covered by a photograph, we have to first take this flight overlapping with a longitudinal overlapping, and again in this direction, in a direction of width, in this direction with a side overlapping of about 30%. So, we have to first we have to calculate number of a strip, and by calculating number of a strip in different direction and multiplying it, we can obtain the number of photograph. We discuss this topic in our next lecture. Thank you.